In this video, we'll talk about what is known as the ideal op-amp. The ideal op-amp makes several simplifications that might seem absurd at first. However, what we're going to see is that by using these simplifications, we can get an approximately correct model for how this device actually works. It should be mentioned that there are many different models for an operational amplifier. In this course, and in a significant amount of the work you're going to be doing in the future, ideal op-amps are sufficient. However, often if you need high performance, you may need to use a more detailed model of the op-amp. We don't consider such models in this course. Let's begin with the circuit diagram. How do we draw an ideal op-amp? There are two ways, one of which is more detailed, the other is not. This is the less detailed way. I have two input terminals, known as V plus and V minus. The op-amp itself is often designated which is the plus and which is the negative terminal. And then here I have V out, which, if you recall, still must be specified with respect to some reference. Normally, when we're drawing the circuit, the reference will be there. In this case, however, we're leaving it out. It's very common to not draw the reference when you're just dealing with the op-amp. The more detailed way is to include two more terminals called V upper and V lower, or V supply. We begin in the same way. We have two input terminals designated plus and minus, and one output, V out. However, we also have two additional terminals. These have different names. Right now, I'll call them V upper and V lower. Now, we'll get into what these do in a moment, but first let's jump directly into certain important properties of an ideal op-amp. Remember from the amplification video that we want an equation V out is some gain times V in. It might be quite strange to you, but an ideal op-amp, the gain typically is called AOL, for A open loop, is infinity. We very rarely deal with actual infinities. However, the gain of a real op-amp is quite large. Often it's greater than 10 million. For the purposes of working with our circuits, it's sufficient to assume that it is in fact infinite. Now, as you can imagine, this isn't what actually happens. If it were, then any non-zero V in would produce an infinite V out. That's clearly not possible. If it were, we'd be able to produce infinite energy, for example. So, although a real op-amp doesn't have an ideal op-amp's gain of infinity, it's a very useful approximation. And let's take a look at what really happens. The big question is, why don't we get infinite output? It turns out it all comes down to what V upper and V lower do. V lower and V upper are the supply voltages. Op-amps don't just produce voltage out of nowhere. We have to give them energy in order for them to produce this gain, this multiplication. So, V lower and V upper are actually two connections to a power supply. For example, Here's our op amp, and let's say this is plus 12 volts and minus 12 volts. These represent the maximum positive voltage and the minimum negative voltage. Our op amp cannot produce voltages outside of the range plus 12 to minus 12, no matter what we do. So, let's now take a look at how we might use the ideal op amp to build something useful. Remember, in a generic amplifier, I have Vout is the gain times Vin. But in an op amp, I didn't have something called Vin. I had two inputs, the plus and the minus. Vin for an op amp is V plus minus V minus. It's the difference in the voltage between the two terminals. So, let's now take a look at what happens when Vin is equal to 1 volt. That means the difference between plus and minus is 1. For instance, it might be 10 and 9, or even 1 and 0. Well, an ideal op amp says Vout is equal to infinity times 1, or infinity. But what about V lower and V upper? At this point, let me draw an op amp in the top of the page. Let's say this is 10 volts and that's 9 volts. Let's put some numbers to this. Let's say this is 12 volts and this is negative 12 volts. If this is the op amp, then Vout is actually going to be plus 12 volts. What happens is, ideally, it would be giving me infinity, but it can't. Positive infinity, to be clear. It has to stop at the maximum, positive 12. We can generalize this. VO is a typical term we use in op amps to mean Vout, is equal to V upper if V plus is greater than V minus, 0 if V plus equals V minus, and V lower if V plus is less than V minus. This behavior is called saturation. It means that no matter what we do, we can never get higher than V plus, V upper, and lower than V lower. You may also see it called clipping. I won't show you what this looks like just yet, because we're going to be moving away from these open loop op amp circuits. When I say the word open loop, what I mean is that there aren't really any more circuit elements inside of it. So we're looking at a pure op amp. Our next step is to look at what we call a closed loop circuit and start using these for practical purposes.